All right, part 2 of the review for cubic and cube root functions. In the first part, we talked about all the stuff that related to the graphs, and in this part, it's really just the algebra type things that we're going to be doing. Question number 5, we want you to write an inverse function to a function that would be a cubed function. So ultimately, that means that you'll be getting a cube root type function created here. Let me switch colors. That one's a bit light. Okay, for these, you do the old switcheroo. You think of the c of x as a y value, but what we're going to do is just call it the x. And when we write this part here, we'll call the x a y. And essentially what you have done here is you have switched the domain and the range. You've actually created an inverse relationship with the thing we have. But what we want to do now is just solve for y so that it is actually a function, and you can set it equal to this. Okay, undoing everything here just like you would be for solving any of the problems that you're going to see in a little while. You want to subtract that 6 first. And the most painful part here is that I need to write all of these steps in between each time we do one of our parts. Okay, next, you've got the negative in the front and then you've got the cubed. Okay, the cubed is actually the parentheses. It's saying everything inside this guy is going to get cubed. So the negative is the item that's actually on the outside part, which is what we're going to remove next. Now when you do that, you're either going to multiply or divide by -1. And yes, you can technically distribute it into the things here. Though the easiest approach at doing this would be to think, you know what, if I just had a number that was right there, if I had a 2 and I wanted to divide it, I could just place the whole thing on 2. So we kind of leave it as well like you're grouping it. And what we're going to do here is just put some parentheses around the x minus 6 and then put that negative out front of it. That way you don't actually have to like change the sign to the 6 and get into any of that. Okay, so just put parentheses around it. If you're not really sure what to do with the step, like how to write it, man, just put some parentheses around whatever you got and then put the next operation outside of it, and technically it's going to work. All right, our next step, we do get to cube root. And the cube root's just going to go around everything, including that negative there. I'll move it over to this area. So we have a cube root, and then inside you have the negative x minus 6. And that would be equal to your 2y minus 3. So you got just a couple more steps here. You're going to add 3 onto the end of this guy. So again, just rewriting a lot of stuff. But we're going to add a 3, which is going to equal 2y, and then in conclusion, you get to divide by the 2. In which case, I would just draw a long fraction bar all the way underneath it and then put the 2, versus attempting to put a 1/2 on the front. If you do that, somebody got to get that 3 included, so it's going to require parentheses or distributing, and it's a lot easier just to stack the numbers here. Okay, so your final answer here is going to be the inverse of c of x is equal to big fraction bar cube root negative x minus 6 plus 3 all over 2. And that's all we really need. Okay, 7, 8, and 9 are all just solving problems. 7 and 8 are, the same thing that you're doing there, but it's actually faster because you get to do things with the numbers and simplify as you go. Okay, so here we want to get the x by itself. We're just going to keep moving stuff away to the other side. You'll begin with the 144. That'll just move on over as a positive 144. And some of these things you could do in a couple steps at a time if you can just keep track of it. Okay. One thing I won't do is I'm not going to show all my work when I go through. I'm just going to start moving stuff around. Okay, the 2/3. There's different ways that this is taught on like how you remove it. The way that I always do, if I have a fraction in the front and I'm just trying to get rid of it, what I do is I just multiply that denominator to the 144, or whatever number you got over there, and then I divide it by 2. You may have heard things about reciprocals, and it's all the same stuff, but I kind of like the flow of just multiplying by 3 and then dividing by 2. It does make it a little bit large at first when you go through, but it's a nice safe way just to kind of go through the problem. Anyhow, 3 times 144. Oh, man. You get a 12, you're going to carry 1 over. You get a 3, carry 1 over. 432. Or, yeah, that sounds about about right there. You'll get the 300, and 3 times 44 would be an 88 plus a 44. 2, 3, 1, 2. Okay, that sounds good. So you get 432. You're then going to divide that by 2 for that number, and that'll drop it down to 2 and 216. Okay. All would be easier with the calculator, but I'm trying not to do that since you're not going to have a calculator for this. But look, when you get to the 216, that's a pretty good sign because 216 is a perfect cube. And then when you cube root it, again, you don't get a calculator, so we're only going to give you perfect cubes here. When you cube root it, you're going to get 6. Simply get 6. And then, well, you want to write things correctly because that would have totally messed up my problem. I got an 8 there. Okay, so then we just subtract the 8 in the end, you get -2, and everything's good. Shouldn't have any issues about answers being right or wrong. You can go ahead and plug it back in, but when you plug it back in, all you're going to end up doing is seeing every single number that you created, which I guess is all right, but you're already going to anticipate those numbers, so if you were wrong, you'll be thinking the wrong numbers. All right, number 8. For this, you do have 2 fractions, so you could do cross products, but in the event that you don't really have that going on in the test, like 2 fractions set equal, I'll approach it a little bit different. Trying to get the x by itself, let's just multiply the 9 to the other side. So think about that for a moment. -1/3 times 9. Right? Don't overcomplicate it just because there is a fraction. Just think about it. -1/3 times 9 is going to turn out to be -3. It's a third of 9, but it becomes negative. Okay, so that gets us to here. We've got a cube root of x minus 7 is equal to -3. Now, 8 is the opposite of 7, so in 7 you needed a cube root to get rid of that. Here, we're going to be cubing to get rid of the 3. So -3 is going to get multiplied by itself 3 times, which is going to give you -27. Well, that doesn't look right, does it? So you got x minus 7 is equal to -27. We'll then add 7 to each side of the equation, and x is, I've spread that out so you really see it, it's going to be a -20. And again, you plug it back in and you'll basically see everything you did, but you get your answer and there's not really too much going on there. Okay, then 9 is going to be more or less like your challenge problem in your answers, in your questions, sorry. What we need to start with, so what you end up with is a binomial that's set equal to a cubed. Now there's a chance that you might have some other stuff on this side. Maybe there's a coefficient in the front and that kind of stuff. But eventually you start moving all these things around, and here's what you're going to get. You're going to get a binomial. There's going to be an x and there's going to be a constant. So it's not just a number. Okay, you can have a little bit more going on over here compared to this cube root, or equal to that cube root. So then when you cube it, it's important that you realize you need to multiply all of this out. Okay? And yeah, it's a little bit tedious. It is. But that's what the problem is. We want you to see that these things exist. It isn't impossible. It'll take you maybe a minute to get through that part. There's some shortcuts out there on how to do this stuff, but for you, just really thinking about multiplying these together, then taking that answer and multiplying by another one. Anyway, it should turn out to be an x cubed plus 6x plus, 6x squared plus 12x plus 8. Should just turn out to be that. Just thinking through my work here, make sure it all looks good. Okay, should be fine. All right, one really neat feature that shows up in all these problems so that they work out and we can continue without a calculator is that these constants just cancel out. Assuming that there is one. Maybe there's not a constant at all in your problem or whatever. But these do cancel out. And what that allows us is that when we move the 7x over to join up with that side, and we set all this equal to 0, let's see, it's not going to happen until the 12. You take away the 7, you get plus 5x. You end up with 3 terms that all have x's in it. which is more likely going to be a factorable problem because you can start with that GCF and divide out the x from all three of them. So we have 0 is equal to x times x squared plus 6x plus 5. And then this part is a very easy quadratic factoring. You're going to have x plus 5 and x plus 1. Multiply to give you 5, but add to give you 6. I can't tell you how many times I've mixed this one up and I've done like a 3 and a 2. So I don't know if you tried before, you watch this video and you see a 3 and a 2. If you flip those numbers around, the product of 2 and 3 gives you 6, but add to give you 5. Okay, and then when you switch them in this order, it ends up that you're using a 5 and a 1. I don't know if you've ever seen that before, but I've done that plenty of times. All right, so your solutions are going to be 0. They're going to be negative 5, and they're going to be a negative 1. And those are them. Okay, now what you should do, it's always a good idea, plug things back in just to make sure that they all work out, but you shouldn't really have any problems with the answers that you got. At least plug them in to make sure that they're checking out, because I mean, you can easily find an error along the way or figure out that you made an error if these don't work. So if I put in the 0, that's just going to give me 8. Cube root of 8 is 2, and 0 plus 2 is 2. Plug in a negative 5. That's a little bit larger, but if I put a negative 5 in here, I'm going to get negative 35. Negative 35 plus 7, sorry, plus 8. Negative 35 plus 8 is going to bring you down to negative 27. Cube root of negative 27 is negative 3. And yeah, negative 3 is negative 5 plus 2. So you can see that these are all working out. There really isn't any issue with your solutions, but please plug them back in. Make sure that they're right so we can give you all the points on it. Okay, in conclusion for our review. Like our last review, at the end, a little bit of a note about some extra stuff that's going to be there, but we're not providing exact problems in the graphing calculator. So the remaining part of everything is actually calculator. We're not missing anything that's not calculator. We want you to be able to use the graphing calculator to find these relative max and minimums that could exist. So you're going to get a word problem, kind of go back to your notes. My classes, what we did was the box where you fold up the sides and you had to cut out the squares. But go back to that question and just think about how you wrote the equation that went with it, then taking that equation into the calculator and how you found the max and min. Okay, so you're going to need to know how to write the equation for whatever the problem is. You're going to need to know how to put it in the calculator so you can find the max and the min. And that's kind of the main parts of it. There's a whole extra conversation about domain, because when you design these functions, values that don't make sense for the problem are not part of your domain. So be considering that also too. I mean, when you do this whole thing, you got to look at the graph and you're setting up a window, and that window kind of answers what's allowed in the domain. And that's it. That's your test there.